Hello, my name is Andy Schweitzer, and I'm going to do a quick little video on just really basic introductions into chemical linear relationships and how we might use ratios or factor label to determine some things that we would use in chemical reactions. Simple chemical reaction, I might say, would be, let's say, burning propane for a gas grill. That is C3H8 plus O2 yields carbon dioxide and water. These are the organic compound with oxygen burning to produce carbon dioxide and water. These are the products. And we're really just assembling and breaking things apart to produce these products. Balancing wise, 3 carbons, 8 hydrogens, some of it a 4 here. 4 plus another 2 to the 3 6 is 10, so I require 5 oxygens here. So this thing, one propane molecule combines with 5 oxygen molecules, produce 3 carbon dioxides and 3 waters. These are all linear relationships between the two. All of them happen at the same time. You can't have one happen without the other. So all this happens in concert. So these might be considered your rates used, and these are your specifically the coefficient, the rate produced. Okay, here's an example. If I were to have produced, or let's say I consume 500 of my propane molecule, C3H8, how many oxygens would I need, and how much of this and this would I produce? Pretty simple example. They combine and form in these ratios. So I'd say 500 C3H8s, and I'm going to get rid of the C3H8 and go to O2. For every one C3H8, this is called the stoichiometric ratio, and this we'll get into eventually, requiring 5 O2s. At this point, if I stopped here, my answer would be 5 times 5, that'd be 2,500 C3H8s that I would require. And simple as that, that one is done. I jumped from here to here is a common way I would describe that. First one finished. That's how much I would need. If I were to consume 500 of these, 2,500 of these, how many of these would I produce? I could simply say, well, off of the 500 or off the 250, you get the same answer either way. Let's do that on the bottom here. Okay, extend the page a little bit. 500 C3H8s dot line. I want to get rid of the C3H8. I want to go to the CO2. What's my relationship here? All right. It says that for every one of these I consume, I produce 3 of these. All right. So it is a 1 of those, 3 of these equals 1,500 CO2s. And I'm going to jump off the 1,500 for my next calculation and say, okay, well, if I produce 1,500 CO2s, how many of my waters would also be produced? This relationship is also locked by the chemical reaction. If I produce 3 CO2s, I will produce 4 O2s. Okay, they have to happen together. 3 to 4 ratio. Again, take your calculator, 15 times 4 divided by 3, and you'll get your answer. 1,500 times 4 is 6,000. Divided by 3 is a simple math, giving us 2,000. 2,000 H2Os. One more O there, 1 more 0. And this is all of our mathematics. Sometimes we will use, for this chemical reaction, what's called an ice table. Would be, and I'll just kind of show you how this would represent. It'd be C3H8 plus O2 yields CO2 plus H2O, and my balancing was 1, 5, 3, 4, 1, 5, 3, 4. Our ice table, this is how I represent it. Initial This stands for stoichiometric ratio. The stoichiometric ratio. And again, that's something that we'll do a lot of in the future, but I have 500 of these. I'm going to lose all 500 of these. I don't know how many I have of this, but I have to have some. I mean, this will tell me how much I need. I have 0 of these to start with. I'm going to have to lose 2,500 of these guys. I'm going to have to gain, it says here, 1,500 and 2,000. Okay, I'll gain 1,500 of these guys, and I'll gain 2,000 of these. So at the end, I would have been, well, if I had 500 to start with, I would be down to 0. It would be however many that I have. I would subtract these two to get how much I have left in the end, minus 2,500, and I would simply have 1,500 and 2,000 of these guys. This is called an ICE table, something we'll use quite a bit in the future. If you knew how many you had here, let's say you had 5,000, well then you would have 5,000 minus what you consumed to get 2,500 left over. If you had 3,000 to start with, well then you would subtract the 2,500 to get 500 left over. All right, that is it. Simple examples of chemical ratios. Thank you.